So hello dear students, welcome to the lecture 4 of this particular course, and in this particular lecture or from this particular lecture we are going to look on the concept of energy band. So from this particular lecture we are going to study or we are going to look upon the concept of energy band. Okay na? So this is the concept which we are going to look or which we are going to study in depth. But before that or before studying energy band we should have a basic idea about certain concepts. And I'm going to explain that concept in detailed way in this particular video. Okay, so let me erase this and we will see what all things which we will be requiring for studying the energy band. Okay, so as you can see over here, the very first concept which we will be requiring, it is known as Bohr's law. So I hope that you might have studied this in your chemistry syllabus maybe, but if you don't have any idea about Bohr's law, need not to worry guys, I'm here to explain you. Okay, so we'll go through its definition, and this is not the traditional definition. It is I tried my best to explain you in short way. So this is very short sentence. It is not the definition. Okay. So in an isolated atom, let me use this. Yes. In an isolated atom, the energy of an electron depends on the orbit in which it is revolving in. Okay. So first of all, we'll try to understand what exactly this particular sentence is trying to tell us. Okay. So let's suppose this is that particular atom, any random atom, okay, and let's suppose this is the nucleus of that particular atom, and these are the two orbits. I had just considered the two orbits. You can consider any number of orbits you want, okay. And I hope you must have, or you at least have a basic idea about K, LM, and shell and orbits, okay, na? So I hope you might know that in the first orbit, or basically in K shell, there are only 2 electrons, okay. So it can hold only 2 electrons, and L shell can hold 8 electrons. Okay, so I hope you know these particular things. Okay, so I'm not teaching you all these things. We'll straight away jump into the Bohr's law. Okay, so what exactly this particular sentence is trying to tell is that, let's suppose I'm considering this particular electron which is revolving, or basically it is moving in this particular orbit, outer shell. I will consider this as an outer shell. Okay, or let's suppose this is shell N1 shell, and this is N2 shell, okay, for a better understanding. So what does this particular line tells us is that, let's suppose this is one electron present in N2 shell, okay, and this is another electron present in N2 shell, okay. So these two electrons, see, this is, let's suppose this is first electron, and let's suppose marking it with A, okay, and let's suppose marking it with B, okay, or highlighting it with B. So electron, okay, the energy of A electrons and energy of B electron is same. This is what this line tries to tell us. Okay, so I hope you understood this particular thing. In an isolated atom, isolated means what? See, isolated, this word is pretty important in as far as the Bohr's law is concerned. Okay, isolated means what? That means it is alone. Okay, isolated means what? Isolated atoms means alone. It is single. Okay, so you might have studied that in crystals, or maybe in let's suppose I'm taking a piece of wood. So in piece of wood there are n number of atoms. Okay, so isolated means what? I had just taken out this particular atom, okay, and I am studying or analyzing this particular atom. Okay, so this is one atom and I'm analyzing this particular atom. So this is known as an isolated atom. So I hope you understood this particular line. Okay, na? So see, the second line is that in an isolated atom, different or discrete energy levels are present. Okay, so what does this means? Before that, let's suppose that this is the electron. These are the electrons revolving in N1 shell. Okay, let's suppose this, I'm considering this as C electron and D electron. Okay, na? So again, the energy of C electron is equals to energy of D electron. Why? Because they are revolving in same shell or in same orbit. Okay, so now in an isolated atom, different or discrete energy levels are present. So this is an isolated atom. So basically the energy level of the N1 shell would be, let's suppose for our better understanding, I know this won't be true, but still for like to explain you in detailed way, I'm considering that the energy level of N1 shell, or basically K shell, is suppose it is 1 electron volt. Okay, let's suppose the energy level of N1 shell, it is 1 electron volt, and that of shell 2 or the orbit 2, it is 2 electron volt. Okay, so this is what we had assumed. Okay, mark my word, this is what we had assumed. Okay, this won't be true in the real life scenario. Okay, and forget about the atom, any random atom you can consider. Okay now, so as you can see over here, in an isolated atom, so this is our isolated atom, different or discrete energy levels are present. So N1, the energy level of N1 is not equals to energy level of N2. That means what? They are entirely different. Okay, they are entirely different, or what I can say, it is discrete. Okay, it is discrete. Discrete means what? In small parts. That means it is 1 electron volt, it is 2 electron volts. Maybe if it has some outer structure, or basically orbit. So this orbit may have, let's suppose, 3 electron volts. Okay, so like every orbit has different energy levels. Okay, so I hope you understood this particular 2 sentences of Bohr's law. Once again, we are going to see it again. So in an isolated atom, so as I said over here, if I consider this particular wood, forget about semiconductors, we are just dealing with the isolated atom. If I consider a piece of wood or maybe metal, so there are n number of atoms. So as you can see, 1, 2, 3, 4, 5. Okay, 3, 4, 5. What I did, I just removed this particular atom, and I'm going to analyze this particular atom. I'm going to analyze this particular atom, or study basically, or I'm going to study this particular atom. Okay, so while studying, what I saw was that the energy of electron depends on the orbit of in which it is revolving. So basically, this was the 2 electrons, although I hope you know that there are around 8 electrons, or there would be around 8 electrons in the L shell. Okay, because I had just considered two orbits. Okay, now that is K and L. But right now I'm just considering that in this particular outermost shell of this particular atom, there are just 2 electrons. Okay, which we had considered that it is let me take different color. Yeah, it is electron A and this is electron B, but they are revolving in the L shell, or maybe N2 shell. What we had considered N2 shell. Okay, now N2 shell. So they both will have same energy, which is 2 electron volts. Same energy, that is 2 electron volt. 2 electron volt. Okay, now while in the innermost shell, again there are 2 electrons, and these 2 electrons, see these 2 electrons will have same energy, which is equal to 1 electron volt. So this is what we concluded from both of the sentences, and at the end we said that in an isolated atom, different or discrete energy levels are present. So that means what? N1 shell or the N1 orbit will have different energy level, as you can see, 1 electron volt, while the N2 shell or the N2 orbit will have a different energy level, that is 2 electron volt. Or maybe if we have some outer shell or maybe outer orbit, so it would have certain different energy. For instance, we are taking 3 electron volt. So this is what I wanted to tell you, and these are the points, like why the energy is fixed. Okay, now why the energy is fixed? Because of the attraction between electron and nucleus. Let me clear these particular things, and we will understand these particular things in little depth, what this particular 2 lines signifies, or what this 2 particular lines states. Okay, so attraction between the electrons and the N means nucleus. Okay, so let me take red color. So yeah, let's suppose this is electron. So attraction between this particular this particular nucleus and the electron. Okay, this is the attraction, and it would obviously remain same throughout. Like the electron is moving this particular fashion on this particular orbit, so the attraction will remain constant throughout, because see, the distance is same. Okay, throughout. So this was the one thing. And the another thing is that, let's suppose this electron is moving in this particular direction, and the outermost shell, the electron present in the outermost shell, it is moving in this particular direction, maybe. So there would be repulsion in these 2 particular electrons, repulsion. And since they are moving with same same speed. Okay, so electron is, let's suppose this is 1 electron, this is 2 electrons. Let's suppose at time t is equals to, and they are moving up. Okay, at time t is equals to 0 seconds, they started their rotation or revolving motion. Okay, so when I saw them in time t is equals to t1 second, and let's suppose the distance between both of them, it is d. Okay, distance between both of these electrons are d. What I saw at time t1 second is that this electron progress further, and again this electron moved further, okay, or progress further, and again their d was same. So since the distance, or basically the path was same, not path, sorry, distance I would say, therefore the repulsion and attraction force remains constant throughout, constant. Okay, but mark my word, the attraction is between the nucleus, and means what? Nucleus of an atom, and repulsion means what? Repulsion is between electrons and electrons. Okay, so as I can see, these are the two electrons, this is 1 and this is 2, which are basically revolving in the two different orbits. Okay, so due to these two reasons, the energy which we consider like 1 electron volt and 2 electron volt, okay, it is fixed. Energy of electrons is fixed. And why it is fixed? Because of these two particular reasons it is fixed. So I hope you understood this particular concept of Bohr's law in great depth. Okay, so I end up this video and we'll meet in next video. Thank you for listening me patiently.